the sound of a keyboard typing rapidly, the sound of a smartphone notification, a digital calculator beep. Text appears on screen one word at a time, as if being typed. Algorithm, algebra, calculus. Think about the last time you Googled something, ordered a rideshare, or even just calculated a tip at a restaurant. You were using a computer, a phone, or a simple calculator. But have you ever stopped to ask, where did the very rules of these calculations come from? The words on screen transform. Algorithm morphs into al-Khwarizmi. Algebra morphs into Al-Jabr. Those words, algorithm and algebra, they aren't just random English terms. They are echoes of a single brilliant mind from over 200 years ago. A man who took the mathematics of the ancients and reshaped it into the language that would one day power the modern world. An illustrated portrait of al-Khwarizmi appears, blending from the words. A map of the ancient world fades in behind him, focusing on the Silk Road and the Middle East. This is the story of Muhammad ibn Musa al-Khwarizmi, the Persian scholar who worked in a legendary library in Baghdad and quite literally wrote the book on how we solve for X. Part 1, The House of Wisdom. A stunning animation of the round city of Baghdad in its golden age. Bustling markets, grand mosques, and at the center, a magnificent library complex. Our story begins in the early 9th century in the city of Baghdad. This wasn't just the capital of a vast Islamic empire, it was the undisputed intellectual capital of the world. While Europe was fumbling through the so-called Dark Ages, Baghdad was shining bright. This is Al-Mamun. At the heart of this golden age was Caliph Al-Mamun. He was a visionary leader obsessed with knowledge. He dreamed of gathering all the world's wisdom in one place. So, he built the Bayt al-Hikmah, the House of Wisdom, inside the House of Wisdom. Imagine a giant research institute, a library, and a translation hub all rolled into one. Scholars of all faiths and backgrounds were invited to work there. Their mission? To translate every important book they could find into Arabic. A young, energetic al-Khwarizmi walks into the library, looking in awe. And it was to this intellectual paradise that our protagonist, a young man named Muhammad ibn Musa al-Khwarizmi, came to work. Part 2. The problem with math. Al-Khwarizmi sitting at a desk, surrounded by scrolls. He looks frustrated. He is looking at a Roman numeral, set 7 plus 14. He scratches his head. As a scholar at the House of Wisdom, al-Khwarizmi studied the great works of the Greeks, like Euclid and Ptolemy. He studied Indian texts, but he kept running into the same massive problem. The way everyone did math was a mess. An animation showing Roman numerals in action. It's clunky. Show a simple addition problem, but the process requires a cumbersome abacus or a counting board. Think about it. Try multiplying x7 by 14 in your head. Pause. Exactly. The Roman numeral system, and most other systems at the time, had no zero and no concept of place value. To do any serious calculation, you needed a physical counting board or an abacus. It was slow. It was prone to error. It was a barrier to progress. A scroll from India unfurls. The symbols 1 through 9 appear, clean and elegant. Then a small circle appears. The 0. Then al-Khwarizmi got his hands on an Indian astronomical text, and within it he found a revelation, a system of 9 symbols and a little circle they called Sunya, empty. The numbers 1 to 9 and the 0 float together. An animation shows how the number 405 is formed, with the 0 holding the 10's place. The visual is clean and logical. This was the Hindu numeral system. It was elegant. It was powerful. By giving a digit a value based on its position, ones, tens, hundreds, and using a 0 to hold an empty place, you could write any number, and more importantly, you could perform calculations with just a pen and paper. Al-Khwarizmi's eyes light up. He starts writing furiously. Al-Khwarizmi didn't just adopt it, he popularized it. He wrote a book explaining this Indian calculation so clearly that it would sweep across the world. Part 3. The Birth of the Algorithm. The title of a book appears in elegant Arabic calligraphy, On the Calculation with Hindu Numerals. His book, On the Calculation with Hindu Numerals, was a how-to guide. It laid out step-by-step procedures, like a recipe, for addition, subtraction, multiplication, and division using this new decimal system. An animation demonstrates a simple multiplication problem following al-Khwarizmi's method. It's the same method we learn in school today. These step-by-step procedures were so central to his work that they became famous. When the book was later translated into Latin in the 12th century, its opening words, Dixit al-Khwarizmi, or Thus spoke al-Khwarizmi, gave a name to the entire concept. The name al-Khwarizmi on screen. It slowly morphs into the word algorithm. Then we see a montage of modern algorithms, a Google search bar, a stock market ticker, a self-driving car, a recommendation engine on Netflix. The Latinized version of his name, al-Khwarizmi, became the word algorithm. So every time you use a precise set of instructions to solve a problem, every time a computer processes data, you are, in a way, channeling the work of al-Khwarizmi. Part 4. The Science of Reunion. Al-Jabr. Al-Khwarizmi is now faced with a different kind of problem. A practical, real-world problem. Show a merchant arguing with a tax collector over inheritance money. But numbers were just the beginning. The real world isn't just about counting, it's about finding the unknown. How do you divide an inheritance fairly according to complex Islamic law? How do you measure a piece of land? How do you solve for X when you don't know what X is? He unrolls a fresh, clean scroll. He dips his pen in ink. This led to his most revolutionary work. Around 820 AD, he sat down to write a book that would change history forever. He called it Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala. A mouthful, right? It translates to the compendious book on calculation by completion and balancing. The title animates. The phrase Al-Jabr glows and then transforms into the word algebra. That word Al-Jabr, meaning reunion or restoration, is where we get our word algebra. And this book was its founding text. An animation shows a simple equation, x plus 5 equals 12. Al-Khwarizmi explains it. Before Al-Khwarizmi, mathematics was mostly geometry or specific arithmetic problems. Al-Khwarizmi introduced something new, a systematic way to solve equations. He didn't use modern symbols like X and Y. He wrote everything out in words. On one side of the screen, an equation in modern notation. On the other, a translation of al-Khwarizmi's words. But his genius was in the method. He said, "Look, there are three kinds of numbers: squares, x2, roots, x, and simple numbers, and you can solve them using two simple operations, Al-Jabr and al-Muqabala." An animation shows Al-Jabr. An equation like x2 equals 40x, 4/2 is on screen. A negative term, 4/2, is on the right. Al-Jabr moves it to the left side, making it positive. x2 plus 4/2 equals 40x. It's restoring the balance by moving a negative term to the other side as a positive. Al-Jabr was the process of completion, eliminating negative terms by adding the same quantity to both sides. Now, al-Muqabala. We now have 5/2 equals 40x. Al-Muqabala simplifies it. It balances by subtracting 40x from both sides, giving us 5/2. 40x equals 0. Al-Muqabala was the process of balancing, subtracting the same quantities from both sides to simplify the equation. The camera zooms out to show the whole process. A messy, wordy problem has been transformed into a clean, solvable form. He then laid out the standard forms of equations, quadratics, like squares equal to roots or squares and roots equal to numbers, and gave the step-by-step methods to solve them. For the first time in history, there was a universal, systematic way to untangle the unknown. Part 5. From Baghdad to Europe. A map showing a book traveling from Baghdad across North Africa into Moorish Spain, Cordoba. For centuries, al-Khwarizmi's work was studied and built upon throughout the Islamic world. But its greatest journey was just beginning. A 12th century European monk, Adelard of Bath, is shown traveling, looking dusty and tired. He is in Toledo, Spain, eagerly copying a Latin translation of al-Khwarizmi's book. In the 12th century, European scholars hungry for knowledge traveled to places like Toledo in Spain, which had recently been reconquered from the Moors. There they found a treasure trove of Arabic learning. The book, now translated into Latin as Liber Algebra et al-Muqabala, is being placed on a shelf in a European university library, like in Bologna or Paris. An English scholar named Robert of Chester, and later the Italian Leonardo of Pisa, better known as Fibonacci, translated al-Khwarizmi's works into Latin. Fibonacci, in particular, championed the Hindu-Arabic numerals and al-Khwarizmi's algebraic methods in his own famous book, Liber Abaci. An animation shows the new number system gradually replacing Roman numerals on ledgers, in clocks, and in books across Europe. It was a slow burn, but the revolution was unstoppable. The clarity of the numbers and the power of the algebra were too great to ignore. By the Renaissance, al-Khwarizmi's ideas were woven into the very fabric of Western mathematics. Part 6. The Legacy in Your Pocket. Fast forward through time. We see Isaac Newton, then Albert Einstein, then a rocket launching. So, why does this matter? Because algebra isn't just about solving for x in a high school textbook. It is the language of patterns. It's the grammar of science and technology. A complex physics equation for calculating a rocket's trajectory is on screen. It breaks down into the fundamental operations of Al-Jabr and al-Muqabala. Without the systematic framework that al-Khwarizmi created, there would be no calculus, no physics, no engineering. The equations that put a man on the moon? They're written in the language of algebra. Back to the smartphone from the beginning. Show a 3D model of a computer chip. Zoom in on the billions of transistors. Show lines of code flowing across the screen. And the computer in your pocket? It is a physical embodiment of an algorithm. A machine that performs billions of step-by-step instructions, the very concept named after him, every single second to let you stream a video, send a message, or find your way home. Conclusion. Return to the animated portrait of al-Khwarizmi in the House of Wisdom. He is just a man with a pen and an idea. The scene fades, and his portrait becomes a ghost, overlaying the modern world, skyscrapers, satellites, data centers. Muhammad ibn Musa al-Khwarizmi didn't invent mathematics. But he did something just as important. He gave it structure. He gave it a language. He took the scattered knowledge of the past and forged it into tools that would build the future. The video ends with a simple equation. Al-Khwarizmi plus curiosity equals the modern world. So, the next time you open an app or solve a problem, take a second to think about the 9th century scholar in Baghdad, the man who showed us how to find the unknown. Subscribe for more stories of the people who shaped our world. Thanks for watching. If you enjoyed this journey into history, please like and subscribe. And let us know in the comments, what other unsung heroes of science should we cover next?